Section 4.2, we're going to talk about the mean value theorem. So a couple theorems we've already done just to remind you, the squeeze theorem and the intermediate value theorem. Okay, those are really the only other two by name that we should know. I know you remember them completely. And now we're going to look at the mean value theorem. Okay, before we start, we're going to look at Rolle's theorem. Kind of gets us to the mean value theorem. Let f be a function that satisfies the following. Both of these, it's really important that the actual I have situations that have to be true. Okay, the hypotheses of the theorem have to be true. So I have a function that is continuous on some interval and differentiable on the open interval. Okay, and if f of a and f of b are equal, if the two endpoints are equal, okay, then there has to be a number where the derivative equals 0 in between there. Hopefully this makes sense if you think about, okay, I'm on some interval, sorry. Okay, so I'm from A to B. If the endpoints, if f of A equals f of B and it's continuous, then it must either be increasing and decreasing or decreasing and increasing, which would make the derivative 0 somewhere in between. Okay, so if this is true, this is what this theorem is saying, then the derivative must be 0 at some place in between, at some c value. That's all that's saying. Okay. Now what's the mean value theorem? Okay, the mean value theorem. Again, I start with a continuous function that is differentiable. So let f be a function that's continuous on a to b. Okay, so we have a function that satisfies the following hypotheses. F is continuous on the closed interval and differentiable on the open interval. So again, if this is true, if my function is continuous and differentiable on some interval, then there must be some x value, which I'm calling c, okay, such that f prime of c, the derivative, is equal to f of b minus f of a over b minus a. Okay, so let me show you what we're saying here. Okay, there's my function. It is continuous and it's differentiable on my interval a to b. Okay, so there is some c value in between here that the derivative is equal to basically the slope of the line connecting the two endpoints. So the slope of the line connecting these 2 points, guys, would be what? F of b minus f of a over b minus a. If you just find the slope between these 2 points, it would be the slope of that line. The mean value theorem is saying that there is some value in here where the slope of the tangent line is going to be the same exact as that. So if I start drawing my tangent lines, where would the tangent line be? Maybe somewhere in here, guys? It would be parallel to that if you look. So maybe somewhere about here. That's all it's saying. This slope, if you connect the two endpoints, the slope of the tangent line somewhere in between is going to equal that slope. That's all the mean value theorem is saying. Okay, now let's do some problems that have the mean value theorem. I have 4 examples using the mean value theorem, okay, or Rolle's theorem. First one, you leave your house one morning and you drive to your cousin's house 300 miles away, arriving 6 hours later. What does the mean value theorem say about your speed along the way? So you start 0 time at 0. Okay, you end 6 hours later and you've gone 300 miles. If I'm continuous the entire time, then the mean value theorem is saying that the derivative in between this time would have to actually be equal to the slope between these 2 points. Okay, so what's the slope between these 2 points? I could do 300 minus 0 over 6 minus 0, and we get 50 miles per hour. So at some time in between 0 and 6 hours, I was going 50 miles an hour. That's what the mean value theorem is saying. Okay. Number 2, demonstrate Rolle's theorem using f of x equals x sine of x. So, first of all, I have to say what? Since f of x is continuous on 0 to pi, and differentiable on 0 to pi, then what must be true? Okay, so you have to say that first, okay, since that's true. And what? F of a equals f of b. So find f of 0 and find f of pi. So go ahead, what's f of 0? If we plug 0 in, we get 0. If we plug pi in, we get 0. So since all of that's true, then there must be a c. Okay, then there must be a c value such that f prime of c equals 0. Okay, the derivative must equal this number somewhere in between. Okay, where in 0 to pi. That's all. Okay, and then we could actually find it. You could actually find the derivative, figure out, but that's all the theorem is saying. Okay, since it's continuous, it's differentiable, and f of a equals f of b, the derivative must also be this number somewhere in between. Okay. Next problem. Verify that the function satisfies the hypotheses of the mean value theorem on the given interval, and then find all the numbers that satisfy the conclusion. So first, what are the hypotheses? Okay, f of x is continuous on 0 to 2 and differentiable on 0 to 2. So now I can apply the mean theorem. Okay, so since it's continuous and differentiable by the mean value theorem, there's got to be a c. What? Okay, so since this is true by the mean value theorem, okay, there exists a c value such that f prime of c, the derivative at c, is going to equal what? The slope of the line that connects the two endpoints, which would be f of 2 minus f of 0 over 2 minus 0, which is what? If you do that out, you get 3. Okay, so what is that saying? The derivative is 3x squared minus 1. So 3x squared minus 1 must equal 3 somewhere, and we could actually find that value. Okay, and I can actually make this c, because we're saying there must be a c value. Sorry, there must be a c value. So I could actually make this c. By the mean value theorem, the derivative must equal the slope of the endpoints. That's all that's saying. And now solve and see what we get. Equals 4. C squared equals 4/3. So c equals plus or minus, but I'm just going to take the positive, guys, root 4/3, because I'm in the interval 0 to 2. So here's the value that satisfies the mean value theorem. Okay, that the derivative at some x value must equal the slope of the endpoints on that interval. Okay. And last problem I have here. Suppose f of 0 is -3 and f prime of x is less than 5. How large can f of 2 possibly be? Okay. If the derivative is less than or equal to 5, okay, from what? We're talking 0 to 2. So we're basically talking about 0 to 2 here. Okay, so the slope of the endpoints would be f of 2 minus f of 0 over 2. And that must be less than or equal to what? F prime of x in that interval. So now I could actually solve this. What do we get? F of 2 minus f of 0 is less than or equal to 10. So f of 2 must be less than or equal to what? F of 0 I know is -3. So this is going to be plus 3. So this is going to be 7. Okay, from the problem, it would turn into f of 2 plus 3 is less than or equal to 10. So f of 2 must be less than or equal to 7. This is kind of another slight variation on the mean value theorem. But again, the slope of the endpoints, and I'm comparing it to the derivative. Since the derivative is less than or equal to 5, then this must be less than or equal to 5. That's all I'm doing. Okay.